Hey everyone, it's Alfred,
Submarine.
and this is episode 136. So in this episode, we're going to be showing you how to set up a Bluetooth mesh network with a Matrix Voice ESP32 version. So without further ado, I'll kick it off to Sam.
Yeah, so we're using two Matrix Voice ESP32s for this. You can actually use more because it's a mesh network, right? So I guess we'll go straight to the screen and get right into it. All right, so we haven't released this guide quite yet, but we'll release it right after the stream. You need your typical Raspberry Pi, Matrix Voice. Actually, I gotta change this. You gotta use platform. Well, you can use Arduino IDE, but today we're using Platform IO because
And really
that's
quickly,
something we found.
let's switch it to this one.
Oh, haha,
Just the camera
sorry.
view.
Yeah. There we go. Cool.
Okay, cool.
Yeah. So, all right. Now you can see us looking at you directly. Okay. Getting started. So, this guide was actually created by one of our contributors, Alexis, and he wrote a really nice explanation of, okay, this is the ESP32. This is the environment we're setting up. We're going to use two of them. And we're going to have one be a Bluetooth client and one be a Bluetooth server. And then for this specific example, the Bluetooth client will be sending data to the server so that it just toggles its LEDs between red and blue. So we're going to build off of the Platform IO guide that we have been building off of the past couple times we've done ESP32 live streams. And so this one is really nice. You can code in Visual Studio and then upload it through Platform IO. So we're gonna get to the part where, so first I'm already SSH'd into my Raspberry Pi. So you would SSH into your Raspberry Pi, the one that your ESP32 is connected to, and you have to sort of clear the Raspberry Pi. So first install the Matrix packages, which I've already done. So to do that, you just literally copy paste this. You can get update upgrade, and then install the Matrix Creator initialization package, and that just initializes all the Matrix packages, flashes the FPGA, all that good stuff. Then you reboot. After that, we do sudo voice underscore ESP32 enable, and what that does is it just like kind of sets up the ESP32 so that it knows it's about to receive data from the Raspberry Pi. And then this clears whatever is currently on it. If there's a program on it currently, or if there's anything else, it just clears it. So it's erasing the flash. It takes a little bit, and then after that we can move on. So I'm actually gonna move on already. So then we go to Visual Studio Code, and we already have it installed, so that's great. And if you need to figure out how to install it, just follow the directions here and go over the links here. Once we've done that, we have to clone the repo. So for us, since we're actually doing the Bluetooth Mesh Network guide, we're going to clone this repo called ESP32 Arduino Bluetooth. It's called Arduino Bluetooth because it is Arduino code that we ported to Platform IO, so it's the same repo. So I'm going to clone it right here, just copy pasted that command, and CD into it. CD ESP32 Arduino Bluetooth. And then if you do ls, you'll see there are three folders: Bluetooth, Bluetooth client, and Bluetooth server. So Bluetooth is actually our general, just starting off, get started with Bluetooth guide. Today we're not doing that. Today we're setting up a Bluetooth client and a Bluetooth server so that two ESP32 Matrix Voices can talk to each other. So I'm actually going to start with the client, so I'll CD into the Bluetooth client folder in my terminal, and clear, and then there's all of this stuff in here. So platformio.ini, and all these folders that are required for the Platform IO infrastructure. So if you go to Visual Studio Code, and these instructions are in the how to set up Platform IO in the first place guide. So the way we've set it up is we expect you to go over the Platform IO guide, which we have a previous live stream that we'll link in the description, where Boris, one of our team members, goes over this, and you can also go over the Hexter guide. We expect you to go through this first and know how Platform IO works, and then do the Bluetooth Mesh Network, because it's the same process. Compiling and uploading is the same process, just you're using a different repo. So we're going to open our project by clicking the Open Project button. And then for me, my project is in live stream. actual, and then that folder right there. So we're actually going to open the Bluetooth client folder because that's the folder that we want, that we have our platform IO configuration in for the client side ESP32 program. So opening that. Once that opens up, it should open up on the side here, and it did. So all we have to do is, honestly, we don't have to change any code for this particular example. I'm going to open the platform.ini file, but if you look at it, all it has is, like, you don't really have to change anything here. You can, if you want, put your Wi-Fi and SSID in here if you want the option to be able to program it over Wi-Fi in the future. But for this particular live stream, I'm not going to do that because we don't really need to program it over the air at the moment. So I'm just going to compile it by clicking on this little check mark right here that you should be able to see. So compiling, I'll make this a little bigger so you can see what it's supposed to look like. And scanning dependencies, great. So it takes usually like definitely less than a minute. It's been like 10 seconds or so for me in the past. And don't worry about the warnings. So once this compiles, literally all we're going to do is flash this to the voice, and we have our client side already. And then we're just going to repeat it for the server side, and we're done. So this is going to be a really, really quick guide. So yeah. And what's really nice about this guide is that you can actually extend it to various, like right here, all it's doing is toggling LEDs on another Matrix voice. But you could, if you want it, have something like a voice-controlled voice controlling a bunch of other voices over Bluetooth.
Yeah.
You know what I mean? Or like, even there's so many different
having
things you could do.
wake word running on the FPGA or the ESP32, and then just like very low power with like TensorFlow Micro or something.
Yeah, like controlling
and then
a bunch.
having the mesh network. Yeah,
exactly. So this is just to set the stage for people to do like way cooler things. So that's really exciting. All right. It feels so slow, but this is the last step, so I know it's almost done. All right. Yeah.
Get in there.
It's getting there, I believe. Well, I wonder if it's done because, wait, let's see. How do I think there's a way to see. Okay.
Oh, there we go.
Okay, cool. All right. Took 100.7 seconds. That felt really long.
It did.
Okay, so it was over a minute. Interesting. I wonder why. Well, okay, so then now that we have it compiled, all we have to do, and this is all in here, you have to deploy it. We just click the check mark, blah, 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 scrolling through here. To deploy it, all you have to do is, here it is. You have to go to the OTA folder and then do /install.sh and your IP. So I'm going to go back to the terminal, and so you see how here there's an OTA folder, cd OTA, and then, so because this is a Mac and I haven't made install.sh an executable, I'm just going to do sh install.sh. I tried / earlier and it didn't work. I mean, to make an executable is easy. You just do chmod space +x and then install.sh. Then you can do /. It should work on Linux. Not sure about Windows, but it's pretty simple. Like I can show you real quick. So if you do chmod +x install.sh, it'll make it into an executable, theoretically. And then if I should do this, I thought it was supposed to change the color.
You, not on Mac.
Okay.
Or not on the default terminal, at least.
Okay. So then you put your IP address, 192.168.1.217 for me. Okay, so that does work. So if you're wondering why it's not working on Mac with the /, just make it an executable, like I just did.
Or sh space install.sh.
Exactly. So you have multiple options. It's all good. Yeah, so this actually, the first time we did Platform IO, I had unknowingly said that you couldn't flash it faster than 115200. That wasn't true. We found later that you can. So this actually flashed at a baud rate of like 15 million or something huge, something pretty big. So we also put in the description of that live stream that you can actually do it faster.
Nice.
So you can So that happened, as you can see, flashed really nicely and really fast. So that's actually, so this is actually done. So I'm going to put the client side, this was the client one, right?
Yeah.
Okay. I already forgot.
That was the client. And
okay.
you can follow the guide.
Yes.
The guide says it.
True. Well, yeah. So I'm going to put the client side voice aside. And now put another voice on here.
I'll hold it. I'll keep it safe.
Okay, sounds good. And this we will flash with the server side code. So, plugging that in, we'll have to SSH back into the Pi. And basically, this is something that I hope people who watch this remember to do. You have to do sudo voice underscore ESP32 enable again. If you if your Pi gets rebooted, and I did unplug and replug it, it will have to remember to set up the ESP32 again. So, Raspberry. Okay, so we're going to do sudo voice underscore ESP32 underscore enable. We're going to erase the flash on this one too, in case there was anything on there, so that nothing interferes with our program. Okay, so while that erases, we'll go back to Visual Studio Code, and just like before, except this time we're going to open the server-side code. So I'm going to close out of the terminal since we already have that. We're going to do open project, go back into, okay, so here, actual, okay, so this time we're going to open the Bluetooth server folder. So open Bluetooth server. And so I'm going to minimize this one so it doesn't get confusing, but Bluetooth server is now in the platform.io workspace. And I'm going to close this platform.ini. So the platform.io.ini file is how it knows what the configuration is for that particular platform.io project. So they're going to be called the same thing, so that can be confusing. But now I'm opening the platform.io.ini from in the Bluetooth server folder. So it's actually different code that's compiling. And I will compile it the same way, check mark, and it runs, executing.
Let's
hopefully
see if it's also 100.7 seconds.
Wow, you remember to the point.
Yes,
I didn't remember.
yes.
Nice.
Or 0.6.
Standard, blah, 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 blah. Would you like to switch? I'm just going to cross this out for now so I don't have to think about it.
No worries.
I'm like, oh, what does that mean?
Yeah.
Okay.
And again, you can ignore the warnings that show up. Like, it's fine.
Mm-hmm.
Know what that is. Static float. I'm curious.
For what's popping up here?
Yeah, what that warning was.
Oh, so yeah, that was it's something about the microphone array. It doesn't like the object use here. Actually, Boris had pointed this out to me before, but since it's just a warning and it still works, we were like, okay. Apparently, if you change the data type, it doesn't throw the error anymore.
Okay.
I don't know.
Okay.
I don't know. I'm not sure. Like, I'm not sure if it's something to do with Platform.io or Arduino itself. Like,
we'll play with it later.
yeah, we can definitely. Oops, I'm gonna bring this all the way down so we can see the progress.
Yes. Ooh, linking. This is a step that we got.
Oh, this is a step. Yeah, this is a step where I was like, oh no, is it gonna fail this live stream? But luckily it didn't. So hopefully this one won't either. And once that flashes, we're basically going to be done. So this is exciting. Let me just put this to the side and scroll through to, I think I can minimize that. So there's more of that. Okay, so let's see. Deploying the Bluetooth code. Okay, so this is just, we will deploy it right after this compiles, and that's the sh install.sh thing. Oh, here we go. Oh, it took longer. Yeah. Okay.
6 seconds longer.
6 seconds longer.
6.23 seconds longer. Or
yeah, not sure.
Seconds.
Pretty odd because I just tested it before the live stream and it was faster. But I don't know. Maybe compiling again. I don't know. You would think that would be faster, but
yeah, I have no idea.
All right, so let's deploy it real quick.
Oh, I know what it is.
What?
It's compiling locally, right? Or is it on the Pi?
I'm pretty sure, on the computer.
Yeah. The computer's running the live stream.
Oh, ha. Smart. Yeah, that's totally it.
If you're doing a live stream while compiling times may be longer.
This is very true. Completely forgot about that. Most of the time, our Mac Mini does make a lot of noise during live streams. Today, it's relatively quiet.
Yeah, yeah.
So I
That's
was
fine.
like, I almost forgot we were doing a live stream. Okay, so we are going to, so we are actually in the OTA folder of Bluetooth client. So I'm going to, as you can see right here, Bluetooth client. We want to be in Bluetooth server, so cding out of that, cding into Bluetooth server, ls, all the same folders. Just the only thing that's different is in SRC, where your main code is, as it says here. The code that you would change if you wanted to do something cooler is different for each, but the external setup and configuration for Platform IO are the same. So we go into OTA. This time I'll do it with SH so you can see the difference. SH install.sh, you just put your IP address, very easy. 217, Raspberry. Alright, so once that flashes, which should be relatively quick, we will check it out on the big screen, I suppose, what it looks like, because it's really simple. And then, so basically what's happening, connecting devices to each other. This is a nice little explanation Alexis wrote. This program is meant to have, oh no, gotta fix that. 2 Matrix Voices, they gotta be all caps. Communicate with each other through Bluetooth Low Energy to change the LED's color. And then, so basically one of them is writing to the other, essentially. And so if you power them both on at the same time, the client side basically commands the server side to toggle between red and blue. And then play around with it, do cool things, and you just compile and upload in the same way. Alright, so, okay, that should be it. So we are going to unplug and plug both of them in at the same time. I'll do it on the table over here.
Yep.
You can plug one in, I can plug one in. At the same time. So here, let me just bring this down, see how that looks. Okay, it's not terribly messy. Okay, so I will switch to this. Alright. Okay, I think everybody can see. Alright, so we are going to plug these in at kind of the same time. Okay, 2, 1, go. Wow. Okay, I definitely failed. I failed. Okay, I don't even remember which one's the client, which one's... Okay, this is the server.
This is the client.
Okay.
I was holding the client.
Okay, so the server is the one that should go between red and blue once it receives data.
Yes.
Okay, let's go at the same time again. Well, actually, I don't know. Well, when I did this before, if I unplugged the client and put it back in, because the client's the one that's sending data to the... There we go.
There we go. Yeah.
It's because the client was plugged in before the server.
That makes sense.
And the server is the one that's supposed to get the... I think it just, like, the timing didn't work out.
Yeah.
Okay, so there we go. So this is basically the concept. It's pretty simple right here. It's just this sending data to this. But as Alexis mentions in the guide, you can actually put, like, both client, like you can combine the client and server side code so they both receive both ways if you want. They can have like 2-way communication.
Okay, nice.
But right now it has 1-way communication.
Okay, it'd be cool to do like a ping pong.
Right? Yeah, that would be interesting. Okay, so that's actually it. Should we come back up, I guess?
Yeah,
I'm trying to think about if I forgot something, but I can't think of something.
It's basically everything.
Yeah. Okay. Is this a good height? I suppose.
Yeah, that's
all right.
That works.
Cool.
Yeah, that's a movie.
All right. Hello. All right. Yeah. Thank you for watching.
Cool. Yeah. Thanks, guys. So announcements. The Hackster contest.
Yes.
So we currently have a contest going on Hackster with Snips and ARM. Basically, the whole idea is for you to use a Matrix device, whether that's a creator or a voice, to do some cool voice interaction thing. Whether that's a smart home device, some like automation thing. Like there's a whole list of examples that we have on the contest. And of course, whatever you come up with, if so long as it fits within the rules, like please submit it.
Yeah.
So you can check out the contest at Hackster.io.
Hackster.io/contest/voice-ai-hardware Link will be in the description.
Yes. Cool. And we announced hardware winners. We were giving out 20 free devices. So we announced that on Tuesday and shipped them out, most of them out today. And yeah, so stay tuned. Hope to see some submissions from you guys.
Yeah, and we actually have like quite a few like events we have like this month or this month and next month that we'll keep you updated on. We have like shell hacks that we're going to.
Yeah, it's a local hackathon with like 1,000 participants they're estimating, so that'll be fun. There's the DevFest.
DevFest, that's end of September. We'll tweet more about that.
And then ARM TechCon, which is in like the second week of October, and that will be in San Jose. So if anybody's in San Jose, you can come meet us.
Yep.
Cool.
All right. Awesome. Well, thank you for watching.
Yeah. Thanks, guys.
And
bye.
See you later.